Good day. Today we are going to take a look at how to simplify rational expressions. And when we're all done with today's lesson, you're going to be able to simplify an expression that looks like the one that I'm pointing at. Notice I have a polynomial divided by a polynomial. All right, well, let's move on to today's lesson. Before I start today with this lesson, I want you to pause the video and do these 7 questions very quickly, just to make sure you're all prepared with the activities that we're going to do today. Now that you've worked through these, let's uncover some of these answers, and let's take a look at to compare. Notice on the first one you have x to the 5th times x to the 2nd. Now, when you have like bases, remember you add the exponents, so you should have got x to the 7th power. For number 2, same type of thing. You're going to add like bases, so you get y to the 6th. For number 3, you're dividing like bases. Therefore, you're going to subtract the powers, and you get x to the 4th. For number 4, again, you're subtracting. So when you subtract, you're going to get y to the negative 3. But remember, you don't want to leave it as a negative exponent. So you write it as 1 over y to the 3rd. For number 5, first of all, ask, does it have a GCF? If it doesn't, notice it has 3 terms, so you're going to factor it as a trinomial. So as you factor it as a trinomial, you'll notice the factors of negative 8 that give us a negative 2 are going to be negative 4 and 2. So here are your answers. For number 6, you can see that you can factor out a greatest common factor of x. So you factor that out, and you got x times the quantity, x minus 5. And for the last one, you factor out an x to the 3rd, and you have x to the 3rd times x. Well, let's work that one out here for a second. When you factor that out, you're going to get x to the 3rd, and then you get your x squared minus 9. Now, you notice that the x squared minus 9 is the difference of 2 squares, and that's how you end up with x minus 3, x plus 3, times the x to the 3rd that you factored out at the beginning. Today we're going to be taking a look at rational expressions. So, if you would please use some Cornell notepaper, or if you don't have any Cornell notepaper, set your paper up so that it is in the Cornell note style, because you're going to be turning this in. So it'll look something like what I drew right there. Alright, so on the left side, rational expression. Rational expression is a quotient of two polynomials. Okay, which means you're going to have a polynomial on the top and a polynomial on the bottom. Here are 3 examples. Now this is a monomial on the top and a binomial on the bottom. And then you have a binomial here and a binomial there. So, making them rational expressions. Now if you go back in your education a little bit, notice 9/24. When you had a 9/24, you could simplify that. You ask yourself, what is a number that goes into both 9 and 24, of which is 3? Because 3 does, you can see that these 3's divide out, leaving you with just the 8 over 3. Now I want you to remember, and there's a little bit of a caution here, remember you cannot divide by 0. So you cannot do that. Alright. Okay, let's take a look at this problem here. First of all, look at the 10 over 6. Is there anything common to both 10 and 6? And hopefully you'll look at that and you'll see, yes, they're both divisible by 2. So you can see with this problem that 2 goes into a 10, 5, and 2 goes into 6, 3 times. So now I have 5 over 3. Now look at the x to the 8 over x to the 4. X to the 8 divided by x to the 4, because you're dividing like bases, you're subtracting the powers, so it's going to be x to the 8 minus 4, or 4. Now, that's half of it. The second half of it is we need to take the denominator. So, let me point to it here real quickly. It's this piece right there. We're going to take this piece right here, and we're going to set it equal to 0 and solve. So, when we solve for it, we're going to divide by 6. I get x to the fourth is equal to a 0. We're going to take the fourth root of both sides, and I will get x is equal to a 0. Now, because the index is even, normally we would get a positive or negative 0. But because 0 is just neither positive nor negative, our answer will just be x equals 0. So, altogether, my answer is 5/3 x to the fourth, and then you put a comma, and then you'll say x is not equal to a 0. And this is how you will write your answer to that problem. Alright, now, you try this one. Go ahead and pause the video, and you try this one, and then we'll work it together. Now that you've worked this problem out, ask yourself, what goes into 8 and 16? Well, 8 goes into 8 once, 8 goes into 16 twice, leaving us with a 2. You have x to the 11 divided by x to the second, which gives you x to the 11 minus 2, or 9. Now, let's find out what x could not equal. So you set the denominator equal to 0 and solve. So first we divide by 8. We have x to the second equals 0. You took the square root of both sides, and of course you get x is equal to a 0. Now, normally when you take the square root of both sides, it's plus or minus. But because 0 is neither positive or negative, we just call it 0. So in our final answer, I'm going to put a comma here, and I'm going to say x could not equal 0. Alright. And underneath this little box, it shows that. Okay. Now here's a question where we're going to be working things out here. But this time, we have a polynomial in the top. Notice, see the polynomial in the top? A trinomial. And we have another trinomial in the bottom. Now, we're going to factor both of those. In factoring both of those, we're going to factor it down. Now, we're going to work it out on the next slide. But on this slide, I'm going to just show you what happens. So, we're going to factor the top, factor the bottom, and then you're going to see that the x minus 1s, see this x minus 1 here? And then the x minus 1 here, they divide out. And when they divide out, it leaves you with x plus a 2 over x plus a 3. Now, you're going to have to set each of these denominators, this one and this one, equal to 0 and solve. And when you set it equal to 0 and solve, it'll give you that x equals 1 and x equals negative 3. Now, notice what happens if you take x equals 1 and x equals negative 3 and you plug it back in to the original equation. In both cases, notice what happens here. You get a 0 on the bottom here, and you get a 0 on the bottom here. That means it will be undefined at 1 and negative 3. Alright, so now let me show you how we're going to work this out in class. In working this out in class, what you're going to do is you're going to factor out each of the top and the bottom. So, you're going to take that x squared plus x minus 2, and you're going to factor it. So this is negative 1 times 2, negative 2 times 1. And I realize because it is a positive 1 right there, it's going to be this factor. So it's going to be x minus 1, x plus a 2. Alright, now let's do the second one here. The second one, you have x squared plus a 2x minus a 3. And I'm going to factor it again. So negative 1 times 3, negative 3 times 1. Notice because it is a positive 2, it's going to be this one. So it's going to factor into x minus 1, x plus a 3. Alright, now we're going to, let me change pen colors, and we're going to write this as the factors. So let me draw a line across here to kind of separate what I've done. And I'm going to put x minus 1 and an x plus a 2 right here. And then underneath it, x minus 1 times x plus 3. Now, do you see anything that divides out? Well, yes. Hopefully you see the x minus 1s divide out, leaving us with x plus 2 over x minus 3. All right, now, one little thing that we need to do still, and that is we need to look and see where it would be undefined. Well, if we set each of the factors equal to 0. So what I'm going to do is I'm going to set, now we're only going to set the denominator equal to 0. So I'm going to set each one of these equal to 0. And in doing so, I get x is equal to a 1 and x is equal to a negative 3. Therefore, my final answer, and I'm going to put it in this little box, this slide is getting a little bit crowded, my final answer will be x plus 2 divided by x plus 3, then I put a comma, and I'm going to say x is not equal to 1 or negative 3. And that is my final answer. Okay, now let's take a look at this one. In looking at this one, what do we see in the numerator? Well, can it be factored? Is there a greatest common factor? Well, no, there isn't. It's only 3x plus a 4. So we can see here that it will not factor. So I'm going to just write it down. Okay, so we have a 3x plus a 4. Now, let's take this, I'm going to put this 3x squared plus an x minus 4 right there, and we need to tree it out. Now this time, as we're treeing it out, notice that my quadratic term has something other than 1 there. So let's write all the factors. So I'm going to put 1 times 3, 3 times 1. For the 4, notice something you need to remember. When the linear term is positive and the constant term is negative, the negative is on which side? It's going to be on the left side. So what we're going to do here is we're going to go negative 2 times 2, negative 1 times 4, negative 4 times 1. Now we're going to do the inside-outside check and see which one's going to work. So in looking at this one, I can see that the 1 and 3 and the 1 and negative 4 is the ones that are going to work. Because looking at it, I can see 4, because 1 times 4 is 4, 3 times negative 1 is negative 3, so 4 minus 3 is 1. And notice right here I had a 1, so that's going to factor down into, so it's going to be x minus 1 and 3x plus a 4. Alright, so now let's take that and I'm going to put it underneath here. So I have my x minus 1 and I have my 3x plus a 4. Now at this point, look at it again, and what do you see right here? A 3x plus a 4. And then what do you see right here? A 3x plus a 4. So because we have the same factor in the numerator and in the denominator, then I can go ahead here and I can divide out the 3x plus 4's. Now, pay close attention. When it divides out, what's on top? Well, it never goes to 0. It goes in there once. So you have left on top, you have a 1 over top of x minus 1. Now, I'm not done, because now I have to do the other half of it. And I do the other half of it by taking each of these denominators, this one and this one, and I'm going to set them equal to 0 and solve. So let's go ahead and do that. So let me kind of create a little bit of a space here to do that. So here I'm going to take the x minus 1, set it equal to 0, and I'm going to take the 3x plus 4, set it equal to 0, and I'm going to solve. So I'm going to add 1 to both sides, giving me x is equal to 1. Here I'm going to subtract a 4, and I get 3x equals negative 4. Then I'm going to divide everything by 3, and I'm running out of room here, so I get x is equal to negative 4/3. So that tells me right here that my answer is 1 over top of x minus 1, and then x is not going to be equal to a 1 or a negative 4/3. So my final answer will be this part that I'm putting yellow around right here. So that is my final answer. Okay, let's go on and let's talk about some. Okay, let's take this problem and we're going to step it up just a little bit. Now, in stepping up a little bit, it will step it up a little bit because the factoring here, both in the numerator and the denominator, well, let's just get into it and show you what I'm talking about. If we take a look at the 6x squared plus the 7x plus the 2, and we factor this, we see here, let's say I have it 2 times 3, 3 times 2, 1 times 6, 6 times 1. Over here, I have a 1 times 2 and a 2 times 1. Glancing at this, it looks like these are the factors that are going to work. So my factors here are going to be 2x plus 1 and a 3x plus a 2. Okay, now let's take the second one here. If I take 6x squared minus a 5x minus a 5, and the factors there, let's see, 2 and 3, 3 and 2, 1 and 6, 6 and 1. Over here I have negative 1 times 5 and negative 5 times 1. Now, to make a long story short, I'm going to go through each of these, do the inside-outside check, and it's going to find out none of them work, which means our answer is going to be prime. It's not factorable. So since it's not factorable, how do I go about doing this? Well, here is the plan. This is what we're going to be doing. I need to find another way of finding where it's undefined. So in order to do that, let's use the quadratic formula. So remember the quadratic formula, opposite of b plus or minus square root b squared minus 4ac all over 2a. Now looking at this, I can see that a is equal to 6, b is equal to negative 5, c is equal to negative 5. So I'm going to plug it in. Plugging it in, let's see, we're going to get negative. I plug in a negative 5 plus or minus the square root. We get negative 5 squared minus 4 times a, which is 6, times c, which is negative 5, all over 2 times a, which is 6. All right, now, what do we need to do from there? Well, let's see. If I simplify that, I'm going to get a 5 on the outside, plus or minus, let's see, I get 25 plus 4 times 6 times a negative 5, which gives me 25 plus 120 over top of 12. So it looks like I get 5 plus or minus the square root of 145 over 12. All right, so that's what x cannot equal. So let's go back up here, and we're going to write my answer. My answer here is going to be the factors of this over top of this, which will not factor, all divided by that radical that I received down below. So my final answer is going to look like this. We're going to have 2x plus 1 times 3x plus a 2 over top of 6x to the second minus a 5x minus a 5, comma, x is not equal to, and I'm going to put 5 plus or minus the square root of 145 all over 12. And that is my final answer. All right, so that's how we handle a problem if it doesn't factor. Okay, so let's stop here for a second and let me ask you this question. How you feeling? You may want to get up and take a little break for a second, and we're getting real close to being finished. Now, for this type of problem, folks, we need to do a little preparation first. In preparing this slide, notice if you take a look at the numerator, see that numerator right there? What do you see right there? Well, I see it's a negative x squared. It's not in descending order. I have to flip this around and put it in descending order. So what we're going to do is we're going to take the negative x squared, put it first. So I'm going to put the negative x squared plus a 4x, and now I need to factor it. We're going to ask ourselves, what's common to both terms here? What can I factor out with this problem? Well, in factoring out this problem, I notice that, and here, before I do that, let me go ahead and just show this piece here. So x squared minus a 2x minus 8. I'm going to go this direction with it, and we're going to factor out a negative x. And that leaves us with an x minus 4 inside. Now, because you guys are getting pretty good with your factoring, I'm going to skip a few steps here. Look at the denominator here. In looking at the denominator, we have to figure out what are the factors of negative 8 that add to give me a negative 2. Well, hopefully you can just look at that and you can see the factors of negative 8 are going to be negative 4 and 2. So, if you're getting real good at this factoring, you can just write it down. You don't need to show all your work if you can just see it. So, it's going to be x minus 4, x plus a 2. Now, take a look at this question here, and do you see anything common to both terms? Well, I hope you see that x minus 4 is common to both the numerator and the denominator. So since it's common, then we are left with here in this question, I'm left with a negative x on top, and I'm left with an x plus a 2 on the bottom. Now, we're not done. That's only half of it. The other half of it is I need to take both of these denominators, this one and this one right here, and we're going to set it equal to 0. So I'm going to take x minus a 4, set it equal to 0, x plus a 2, set it equal to 0, and solve for it. So I get an x is equal to a 4. Over here we subtracted 2, so I get x is equal to negative 2. So my final answer is x is going to not be equal to 4 and negative 2. And there's our final answer. Okay, now you try this one. So within your notes, go ahead and pause the video and you try this one. Alright, now that you've had a chance to do this, let's go ahead and just work it through here. So first of all, I'm going to write my numerator right here, the 10 minus 2x. And I'm going to put my denominator right here, and let's factor each piece. So in the top, first of all, I see that I can put it in descending order. Then I can factor out a negative 2, and I get negative 2 times the quantity x minus a 5. Now, this piece over here, it's prime, so I can't do anything with that. So that leaves me with, on the top, negative 2 times the quantity x minus a 5. On the bottom, I have an x minus 5 as well. And we see that we have some things that divide out. Turns out, this divides out. Now, when it divides out on the bottom, you're left with a 1 down there. So you have negative 2 times 1, or we can just say the answer is negative 2. Now we need to find out where x is not, what x is not equal to. And hopefully by now you can look at the bottom. If you need to, go ahead and set that x minus 5 equal to 0 and solve. But if you can see it, you can just write x not equal to a 5. Now let's take a look at the calculator here a little bit. Let's look at what the graphing calculator will show us. If we take a look at the graphing calculator here, and let me remove this box. Now that we've removed this box, I want you to kind of see what's happening here. If you look at this question, you can see that x was not equal to 5, and look at what you see right there. It says x is not, has an error at 5, so x is not equal to 5. Okay, everybody, how we doing? Now this is going to pretty much wrap it up for today. Tomorrow we're going to be looking at multiplying rational expressions. But again, as the little bear up says, that is for another day. Tonight's homework, we're going to be looking at 8-2, 1 through 7, and then 18 through 23. Have a good day. We'll see you tomorrow.